please come in. So our next talk will be by Ziping Zheng about You Might Not Want Async. Please give him a warm welcome.
たくさん人が集まっていますね。皆さんおはようございます。私は表の通り日本人ではないです。台湾人ですけど、日本語はちょっと喋りますから、まだまだ未熟なんですが、これから先は英語でお送りしますのでお許しください。Okay, so あとPyCon JP は2度目なんですけど、まだまだ人は知りませんが、もしこの後、どこかで見たら、気安くに声でかけてください。はい、ありがとうございます。Okay, so this is one of my dreams to present something in Japanese in front of some people. Okay, this is my title. You might not want async, and this is sort of a killer topic because I just want people to pay attention to the topic. And actually, I'm not really talking you like off async. Okay, this is a presentation especially for Japanese people, and this is my name in kanji. And if you want to pronounce it in Japanese, it sort of sounds like that. Okay, so you can try. And I'm on Twitter, so you can follow this account. Okay, and this is a normal introduction. You can, and if you are not Japanese or you just don't want to speak Japanese to me, you can call me TP. This is my initial, right, for my name in English. And you can follow me on Twitter or Facebook. You just search for the account. I'm on that. And I also have a website with the same name. And if you have difficulty typing that address, I know a lot of people do. You can use a QR code right here. Okay, nobody is interested. Good. As expected. Okay, I'm an organizer for Django Girls Taipei. Django Girls is a non-profit organization for teaching women to get into the technology field. We built a website in Django with them in one day and teach them how to install Python and Django and doing pip and doing some web framework stuff. I'm also, this is very off topic, but I'm also the author of Markdown, which is a Markdown editor for Mac. And if you're interested in doing some Markdown and with some like live preview, you can check out in this address. This is my company. We do agricultural farming stuff. We put sensors into the field, and so if there are environmental changes, for example, if the temperature gets too hot, we can collect them to our server and send a notification, SMS or email or like push notification to farmers so they can check it out. Okay, so the crops don't get bad. And I'm also the chairman for PyCon Taiwan 2016, which will be held next year in June 10 and 11. We're planning to do that. We don't know yet. But if you're interested, you can visit our website, which is pycon.tw. Okay, so first, some quick questions for everybody. How many of you have done anything in concurrency? Oh, that's like almost everybody. Thank you. And which of them are in threads? Okay, and multiprocessing? I think you just keep your hands raised. And how many of you have experience with single thread asynchrony? Not necessarily Python. You can do it in like JavaScript or, okay, that's considerably fewer. Good. And which of them are in Asyncio? Okay. It's much more than I expected. Okay. So I got into Asyncio, asynchrony programming, or rather Asyncio, the first time in 2014, which is like 2 years ago, right? And I speak about it in this called osdc.tw, which is open source developer conference in Taiwan, okay, which was canceled after I speak. So this is the last ever OSDC.tw. I think I just cursed them somehow. Okay, so I talk mainly about Twisted at the time, and it was pretty fun. So I decided that maybe I should check it out more. So I did a similar talk, but more Python and again in PyCon TW. This is rather PyCon APEC 2014 in Taiwan, and I talked for the first time about Async IO, which is by the time very new in Python. They just landed in 3.4, right, which was 3 years ago, and the reaction was like not a lot of people are interested. And I have a big problem. I kept wondering why, because this sounds like a very cool topic and everybody should be interested in. And I realized the problem. The real problem is that Python 3.4 is released in March, right? So they released it in March and have a introduction talk in PyCon US about like some weeks ago. And OSDC is a month later, and a month later is PyCon APEC. So virtually nobody in Taiwan has ever heard about Async IO by that time. So it's obvious for me, well, afterwards that it is obvious that nobody would be interested in Async IO. But, and then 2 years passed, right? And there are more and more talks about Async IO and asynchrony in general in Python. There are more talks about Tornado and Twisted. Twisted just got a new major release, I think, last month or 2 months ago. And there are a lot of comparisons, and there are even alternative implementations about event loop, like UV loop, about something. And this got me thinking, maybe I should do that again. But this time I want to do it a bit differently, because everyone is talking about how wonderful asynchrony is, and how cool Async IO is, and how cool the new keywords await and async are. So this time I want to sort of like share my experience with everybody, because after I did that talk in 2014, I started using Async IO in our company to build our new service, as I said, about agricultural things, right? We collect stuff and we do a sort of like event-driven thing, because when the temperature gets up, we get sent a notification and we can like relay them to the farmer. So I kind of had some experience about it. So this is the gist of my talk. It's dangerous if you are trying to do Async IO, and you might want this advice, sort of. Okay, so this talk is mainly about if you have a little experience about Async IO, this will be very suitable for you. And if you are very experienced with Async IO already and you are very committed to it, like I am, this might not be for you, because after this talk, you will still be using Async IO and everything I say would not apply. So there's still time to leave. And okay. And if you have no asynchronous programming experience prior to this talk, you should probably just leave now, because what I'm going to say will be like gibberish for you. Okay, but for those people, okay, everybody's saying cool. So for those people who does not know what async programming is, here's a little like introduction stuff. First, so let's think about this. So if I have like 3 things to do, and each thing contains 3 parts. Like this is the first thing. In the first part, I want to do something in my program, like for maybe a for loop or something. After that, I want to wait for a thing. Maybe I want to talk to another thing through network, maybe to visit a website, or maybe just wait for user input. And when I got the response, maybe I got a user click, I can do something else. Okay, and after this, I have I can perform another thing. But the next thing, the 3 things are not related to each other. So I can do one thing and then do another. So the order is not significant. Okay. The only thing that's important is that I need to do something upfront, and after the wait, I can do something else. Okay. So in a synchronous approach, we'll do things like this, right? The first thing, and I wait, and I finish the thing, and I do the next thing, and wait and finish the next thing. Likewise for the third. Okay. And this is the synchronous approach. Now, if you want to do the three things like finish faster, then in a synchronous approach, there are a lot of ways to achieve that. The most simple, I guess, the approach is by threading. So you can put the three things, because they are not related to each other by any means, so you can put them in 3 threads and do it like concurrently, right? So you can wait concurrently. But there's a problem in Python because we cannot actually do threading, right? We can only use one core at a time. So the only way the Python can be released and to do other stuff is when the program is not doing something else. So you need to like put it in here and this one. So this gets really complicated. So there's another thing. So we kind of get to the other approach, which is, I think, implemented by other language, maybe Lua or something, and got really like heaped up by JavaScript, which is called single-threaded async. Right? For example, in JavaScript, you have only one thread, which is the UI thread. So you do everything, and everything is done with the UI. So if you do many a lot of intensive computing, you'll block the UI. But if you're not doing something very intensive to the CPU, maybe you are just waiting for a network response, right? Like doing AJAX, when you send a request and you're just waiting and you're not actually doing anything inside the code. The code can release itself so that other parts of the code can do something else before the request needs to finish this job. So in a single-threaded async, we kind of do the three things like this. Like this is the first part of the first thing, and when it starts waiting, you can do the second thing immediately because it's not doing anything else otherwise. So you can like sort of like fill all the gaps and yeah, just like that. Okay. And if we compare the two like approaches, you say it's magically doing everything faster, but it's not really that. It's I'll talk about this later, but not everything is finished faster, right? For example, the first thing, the purple one, you'll see that the synchronous approach actually finished faster here. Right, because the async approach needs to wait for the first part of the second thing to finish before it finishes the first thing. But that's another thing we can talk about later. But for me, for the 2014 me, it's just magic. Everything is just done asynchronous and everything's done. Like for me, it's like sort of like before you're using async, and after that you can just boost your code like cost-free. You don't need to do anything. But after I played with it, like using it at work, which is pretty dangerous to use something you're not familiar with at work and work for some time, I realized that it's not actually the case. It's sort of like this. For anyone who's everyone, I guess this is Faust. Dealing with the demon, so he's trading with the demon for his life. This is what asynchrony really is. You're trading something for the magic power you get, right? But in the meantime, you're giving up a lot of things else, and you're like playing with fire or demon or hell, or yeah, you get your life drained. Yeah. Okay, so now we compare the two. You can see that the first job, as I said before, finished a bit faster. in a synchronous approach because it does not need to wait for the second job, the first part of the second job, anyway. So this is something to keep in mind in when you do async IO or async generally. The things will not always finish faster, okay? It does not magically make your code faster. It just sort of like fill the gaps. When your code is not actually do something, you can fill the gaps with some other parts of code. But this costs time. So if your code does not actually like wait a lot of things, for example, you're doing like scientific computing, you're using a lot of CPU, using async IO will totally not make your code faster. It will very likely make your code a lot slower. So when you're doing the thing about async IO or async, sorry, when I say async from now on, I'm talking about single-threaded async, and when I say async IO, I generally mean async. Okay, it's just a mistake I usually make. Okay, so where was I? Oh, so async is not always good for you because of these three things, mainly, I think. First, apart from the little thing I just mentioned, it infects your whole program because if you're doing async, your whole program needs to be async. You cannot do just like one part of it. Oh, this part of my code is very slow, so I'm gonna do this in async. And other parts, okay, let's just keep it as is. It does not work that way. If you want to do something async, you are very likely to infect your whole program, or at least a very big part of your program, to become async as well. So the code can work together. Okay. So this means that if you have existing programs, for example, you already have a framework or you already have a working application and you want to convert it to use async, this is generally not possible without like completely rewriting your whole program. And secondly, async is not parallelism, which means that if you have something that is not actually waiting, is doing CPU intensive work like scientific computing, async will not help you at all. And if you are interested in doing multiple things at the same time, not at approximately the same time, but exactly at the same time, this is not possible in async. Okay, and last but totally not least is third-party support. Async in general and async IO in Python is very, very new. Twisted and Tornado are very mature frameworks, but they do not fit very well with the rest of Python. So Twisted sort of like have its own ecosystem. And if you want to use async IO, there are virtually no to very little third-party support. So you will need to consider that when you try async. For example, if you're doing like a SQLite application, you are using the built-in SQLite 3. SQLite 3 does not support async IO. You will totally block your program, and you will need something else. For example, let's take a look at the SQLite application, as a matter of fact. This is a very simple SQLite 3 application, right? I connect to a file, a SQLite file. I open a cursor, I select something out, and I get the data, and then I close everything, clean up, okay? So how do I make this async? It's very, very obvious, okay? Very, very obvious. You just do one simple thing. You just rewrite everything, okay? So what do you need to do to convert this? First, you need a new library called AIO-ODBC, which is a asynchronous ODBC database like connector. And then you use a set of new APIs. Instead of using the SQLite.connect, you need to do that blur. I don't even know what that is, what that means. And this is a very simple example, so you just make one API change. In most of the cases, for example, if you're doing a HTTP like networking thing, you probably are familiar with the requests. And if you want to do a async IO version, you will need to use a library called AIO HTTP. And they have like 60% similar. So you need to rewrite about 40% of your program. And last, you need to add a lot of those green words. Did not exist in the synchronous version, but you need them in async version. Okay, so you can actually use the async features. Okay, so the program, the function is finished. Now we need to use it. And this is how you use it in the for the synchronous version. You just like call the function and print it, right? It's simple. And how about we use the asynchronous version? You need what do you need to do? Rewrite everything, right? So you need to import something else called async IO, and you need to decorate the function. You need to write like those boilerplate. Those boilerplate appear everywhere in every program you will ever see in async IO because they are just necessary. Okay. By the way, this is Unicode 9.0 new emoji shrug. But okay. Now this is the program I gave you previously. No, actually it's not. There's something wrong with this. Can anybody see what's wrong? No? Okay, let's run this. You get this? Yeah. And what's wrong? You need this, right? So I just missed one word and my program just doesn't work. The problem is that the program I just showed you, the wrong one, it's still 100% valid Python. There's no syntax error at all. So the interpreter cannot help you until you actually make a mistake and you run into the mistake and you just, everything just blow up. And you just wait 3 hours of networking and everything just is not done. Oh, but I know. I can just write unit test, right? If you unit test the code, you will know that it's not doing exactly what you're trying to make it do. Okay, so you're going to write unit tests for async IO programs. Okay, actually, good luck with that. So this is a very difficult program, a very difficult thing to do, to write unit tests for async IO, right? It's so difficult, you can actually find a Stack Overflow question for that, and you get like a tons of comments. But I'm not talking about how you can do async like unit tests. If everyone is interested in writing unit tests for async programs, I suggest you to listen to a talk called Eventually Correct, which is given by one of my favorite speakers, Jesse Davis, and at PyCon US this year, I think. And he'll walk you through on how you can write asynchronous unit tests for asynchronous programs and how they actually work and how they actually does not work. Okay, but I'll touch on the main problem I faced and he talked about. So let's write a unit test. Let's say I have this very simple program, right? I print the current time and I do something that costs 2 seconds. In this case, I just sleep, but in an actual application, you should do something that really does something. Maybe you go talk to the network, and then after I'm done, I print the time again. So if I run this, I get something like this. So before it's sort of like this, and after I'm done, I get a delay of 2 seconds. So I'm going to test this. Okay, so let's use the built-in unit test framework, right? So I write a unit test like this, and because I'm testing a asynchronous function, I need to write a asynchronous coroutine like this to test it, and I just do this, right? And I run it. So does it work? It does. Okay, everything passed. So what's the problem? You just say it's difficult, but everything passed. So what's the problem? Yeah, it's running too fast. It just finishes in 0.02 seconds, which is totally not right. So what happened? Unit test does not have any knowledge about Asyncio because it is obviously written a lot earlier than Asyncio is ever invented and thought of by Guido. So coroutine methods are just executed. So a task is created and it's never run and the test finished. But the test was created successfully, so unit test thought everything just runs smoothly. Okay, the coroutine you wrote is called and a task is created, but the actual content is not executed or awaited in Asyncio terms. Okay, I told you it's going to be difficult. So how do you solve the problem? You can write a decorator like this, which I extracted from the Stack Overflow question I just mentioned. You need to first create an event loop for your tests. You should set your event loop to Asyncio, so it will use your event loop, and then you use the loop to run your test function, which is going to be decorated. And after everything is done, or after a exception is raised, you close the loop, so you clean out everything. So this is again the boilerplate I just mentioned in the previous example. Okay, so by the way, if you have prior experience with Asyncio, you might know that there's actually a Asyncio.get event loop, not new, but get, which gets the current event loop. It will work if your test all passed, but I do not recommend that. I think you should always use the new event loop for your tests because then you can have proper test isolation and you don't like leave things behind after a failed test. So always use the new event loop if you're testing something. Okay, and you decorate that, and this one will pass. And what we're expecting will actually be done. Oops. Okay, so tips. First, you should always, in Python 3.5, they added some extra features. So if you have a unrun task in your application, it will emit a warning before the application finishes. So actually, you can, I cheated a little and hide a standard error output in the previous example. But you need to be aware of that. Okay, and a tip I find pretty useful is to add coverage report to your test code, not your actual application, but your tests. So you can know what tests are actually run and what tests are actually not run because you forgot to put the decorator. And also, the decorator is bundled into a pip library called async tests. You can just download that and you will have contain that decorator. You don't need to put that write that decorator yourself for all your programs. Or you can just use PyTest instead, which is my approach. Last. So this is a PyTest test, right? And you just put some asynchronous code in the test, you will magically fail, which is, I believe this is actually not intended behavior, but it just happens. So at least it works or does not work for that matter. And for the test to work, you need to download a pytest-asyncio to install that and put this decorator, and everything will work. But you still need to remember that decorator or everything will not work, which is... Okay, so I've used about 30 minutes and I'm still not done. Cool. Okay. In the next part, I'm going to talk about Asyncio itself because Asyncio, it's, when you're doing, because I come to know async programming from Lua and JavaScript, and later I tried Asyncio in Python, and the difference between JavaScript async and Python async is just like this is Python. I'm sorry. Async sort of works, but it's feel like it's like glued up to the standard library. That it's not actually the language itself is just some afterthought that you. It is just weird Frankenstein sort of stuff. Async has three main problems, I think. First is boilerplate. As I've shown you, you need like 3 lines of code that you don't actually know what they do, and it's very error prone because it just leaves a lot of holes because async does not actually work very well with the syntax of traditional Python, to say. And the API is pretty immature, but the last one is very fixable, right? Because they just released it in 3.4, so the last one is not something I really worry about, but the first 2 ones are. Okay, so let's talk about this. This is requests. Everybody should know requests. I think if you don't, just Google it right now, like because you should. And this is a very simple example. I want to collect contents from those URLs, a list of URLs. Okay, so I just run request get for every one of them, and if I get an error, I just don't do anything in this case because I want to keep the code short. And if I do, I just collect the content and append it to a list and just return it. This is very simple, right? So I want to do this in Asyncio. Okay, so in Asyncio, I need to use another library called AIOFTTP, which will look like this, which is a sort of like 60% root right. So this should work, right? I created a session and I get the URL for each session, and yeah, this should work. This totally would work, right? Okay, I'll tell you this actually does work. I'm not doing anything wrong right here, but it will not run faster than the synchronous version, right? So the gist is like this. One does not simply async await and make your program magically asynchronous. The problem is here. I'm doing await in the for loop. So I'm actually, when I'm doing this is actually like, I wait for the first thing in the first iteration, and the second thing, and the third thing. So the requests are still synchronous. The requests are asynchronous, but the for loop is still synchronous. So nothing. So the program does not actually run faster than the request version. Okay. So this is wrong, right? I wait this in a for loop. So this is wrong. So how do I fix this? I need to do something like this. First, I need to collect all the coroutines, which is response.text, which is a coroutine. And after I collected all the coroutines from the for loop, I can wait for them in a asyncio.gather. So I can wait for all of them. Okay, this is sort of like joining threads, right? And not actually an improvement to threading, if you ask me, which is. And by the way, I used something called asyncio.gather, which takes a indefinite numbers of coroutines and wait for all of them. And there is actually another method called asyncio.wait, which also waits for a set of futures, a iterable of futures. But instead of returning the results, you're returning whether they are successful or not. Okay, this is all good, but the APIs are different. You see that? Gather takes a indefinite number of coroutines and futures, and asyncio.wait gets a iterable of futures. And why is that? I don't know. Don't ask me. I don't know. I have no idea. So if you have any ideas, for example, if you know Guido personally or something, maybe you should ask him. Please do. I'm very interested with his answer. And this is for PyCon JP only. Why? I'm not doing this, sorry. So, got me thinking that maybe we should do something else, not async IO. If you want to try something else than async IO, concurrent and multiprocessing is always there, and you can use them. They're very old, but very good. And there's also something called Greenlets, which is a C extension taken out from stackless Python. And they have a similar idea to async IO, but they are less infectious and they work in Python 2.7 as well. So you can try that. And of course, you can always use threading. And threading works very well with networking code because networking code does not actually block your other parts of code because Python actually releases the GIO before it does some standard IO and networking stuff. Okay, so you can check out Greenlet. And I know some of you are thinking I'm missing something, which is called G-event, but I do not actually like G-event, so I'm intentionally skipping it. But if you're doing G-event, it's fine. Okay, and last, let me present something different. This is Go, right? So Go, I have a lot of problems with Go. I do not use Go at all, and I think it's a terrible language. Sorry if there any Go lovers down there. Please don't come at me. And but I still think Go is not very good. But they do one thing great, which is asynchronous programming. Now this is a synchronous Go program, and what do we do to make this Go program asynchronous? You guys just do one thing, and that one thing is not rewriting, it's actually one thing. You just add one word, and the test will magically become asynchronous, just one word. Okay? Actually, it's not. You need to do this. Okay, but it's just 4 lines. It's a lot better than async IO. Okay, this actually runs. So the Go model is a lot better. A lot better. It's not error prone because if something doesn't work, it actually does not work, right? It does not have a lot of boilerplate. It still has some, but very little. And the API is very good, I think. Now, this is the Python version, the Python counterpart of that Go program. And if you want to turn this into async, you do this. This is what I call boilerplate, right? Python. I'm sorry. Now, can I just do this? Sort of like async IO run event loop, and everything just magically get awaited. Is this possible? No, it's not possible. But we can dream. Maybe in Python 6, you'll get that. Okay, so recap. I'm running out of time here. So you've spent more than 30 minutes listening to me complaining about something and complaining more about something and more. So I'm sorry for your time loss. And I gave you some successful advice that maybe you should not use async, you should use something else like Greenlight, or you should just stuck to threading. But I'm using async IO, so if you want to, I'm here to help you. And right, seriously, asynchrony is not the silver bullet for your problem, and you need to find what your problem actually is, and if it actually can be solved by async IO, you should try it carefully so to make sure that it actually solves your problem, and if it does, then you commit to rewrite everything in async IO. And when you're rewriting, you need to remember that async IO will make you jump through a lot of loops, so that you need to be careful and don't get burnt. And if you're not happy, there are always alternatives. And if you exhausted every possibility and you need to write async IO codes, fingers crossed. Okay, this one for everybody. Thanks.
All right. Thank you, TP. We have a few minutes for questions, so please put your hands up if you have a question.
日本語でもいいで。
Or Chinese.
Chinese, yes.
Or German, I can translate. So now you really don't have an excuse, yes.
Thank you for your presentation. I've never used Python 3, so I'm very new to Async in Python 3. So I'm not sure, but you listed some error-prone cases. For example, tasks are not awaited. Do they covered by type hints in Python 3?
Unfortunately, no. Actually, yes, because if you return something wrong, right? If you are returning a coroutine in a function, then it can be catched by type hinting. But if you're not actually returning, or if the thing is bundled inside the function, it does not pass through function boundaries, then type hinting cannot help you. Yeah.
There is an environment variable.
Really?
Yeah.
Yeah.
Python async IO debug 1 will tell you that you're not awaiting a coroutine.
Oh, yeah.
But that's not typing.
Yeah, that's not type hinting. That's when you run the code. Yeah.
Other takers, come on.
Seems like there's so many alternatives to using async, like streamlets and multiprocessing. So why even bother to learn this?
Yeah, because, for example, multiprocessing has its own pitfalls as well. And yeah, it's just different pitfalls. Yeah, Async IO is, I think Async IO is very attractive because it works well with other kinds of event-driven stuffs like WebSockets or GUI programs or web apps, right? So if we're waiting for user input, it integrates very well with Async IO. So it's sort of like, it's not, Async IO is not here to replace threading or multiprocessing. It's here to live with all of them and become an alternative to when you have a suitable problem for that, I think.
Well, I mean, like, so for instance, Twisted does it very well, right? And then you have libraries like ZeroMQ that also uses the Twisted event loop. And so you say that the PyTest has support for testing async, like doing async unit tests. So like main ecosystem is in the Twisted world.
So why Async IO, right?
Yeah.
Well, not that. This is a very good question, and I don't know the answer. You have to ask Guido. Yeah.
But maybe it's a like transition phase, or
Uh,
try to integrate more of the Twisted into the main.
Yeah, the idea, the idea is behind Async IO is that you can actually have alternative event loop implementation. So you can implement the twisted event loop inside the Async IO event loop, and you can implement the tornado event loop inside the Async IO event loop. So you can use the same set of API to access twisted and tornado or some other Async IO framework. But that's provisional and is not implemented yet, I think.
I also agree that there's a lot of like magic stuff when you use like Twisted.
Yeah.
The loop and like if you're lucky, your library integrates with it, and if you're not lucky, then
Yeah. Yes. Yeah, Twisted is very good, and if you're already using Twisted, I suggest you just simply stick with it. Yeah, don't need to switch just because there's Async IO.
Okay, again, thank you very much. This is all the time we have. So next up is lunch, which will be on the first floor in the cafeteria. During lunch, please go talk to